Welcome to the Endless Loop, where the technology journey is endless, the loop never breaks, and innovation never stops. Today, we move on to part 2 of creating our Kubernetes laboratory cluster using VirtualBox. Let's get right to it. Now, if you followed the first video, your VirtualBox setup should look similar to this, where you have 4 virtual machines, all running Ubuntu server 22.04 LTS. All right, so as you see here, I have the Kubernetes master here. That's one node. All right, this is another worker 1, worker 2, and worker 3. All right, and also your memory and your CPU specs for each node should look similar to mine as well. All right, so taking a look at that, click on settings. All right, it's kind of graded out. That's because this machine is running, but you can see here 4096 megabytes for your memory. All right, and then you have 3 CPUs allocated. All right, so this is going to be the same setup for each machine. We're just going to jump directly to the settings for worker 3. All right, so same thing. All right, so 4096 megabytes processor. All right, and 3 CPUs. All right, so that's good to go there. All right, then also to reach each machine via SSH from your local terminal, you should also have a NAT network set up. All right, for each one where you've configured port forwarding from your local machine to the virtual machine. So let's take a look at that. All right, so this is where you go for that again. If you guys remember, so network manager. All right, so you have NAT networks set up, and I have a bunch of stuff here. So let's just take a look at one. Let's see here. Let's take a look at this one. All right, so this is the name, generic name, right? TCP protocol. Host IP is going to be your local machine. The host port to reach the machine is going to be this from your local machine. All right, so you're just basically tunneling through a port. All right, and so this is going to be the guest IP address that you want to tunnel to, and this is port 22, which is the default port that SSH runs on. All right, so same thing. So node 1, node 2, node 3. These are the IP addresses for each one. All right, and then the master node is somewhere in this list. All right, and so another thing that's very important, for functional security reasons, is that also each one of these nodes also should be up to date with the latest package updates. All right, so if you remember that step, just going ahead and just logging in just one node. All right, so clearing this out. All right, we should have run sudo app update and sudo app upgrade. So that should be good to go already. That's what we did in the again part 1 of this tutorial. So we don't have to do it again. I'm almost certain if we run a sudo app update since I released the first video, there's going to be some packages, some recommended updates for some packages. So we don't have to do that right now, though. This update is just going to update the app repositories. So 44 packages can be upgraded. So since the last time we did part 1 of this video, in the repository list for the Ubuntu 22.04 server, there were 4 package upgrades, 44 package upgrades. We don't have to run that though, so I'm going to clear that out. All right. So that's been completed again. So now, again, the actual NAT network. All right, so that's set up. So that's going to allow us to reach each node from our local machine. All right, so let's go ahead and do that. All right, so as you see, as we saw already, it's already running each server, each node. All right, so if you remember the port address from the first video, all right, so we started off with 2301. So 2301 all the way up to 2305, I believe. So this is how you SSH into it. All right, so SSH -P, that's going to be the port. This is going to be your local machine. This is basically telling SSH that you want to tunnel through your local machine directly to your VirtualBox machine. So if you do that, 1 second. Okay. All right, so entered in the password, and so that's that. All right, so we're going to do the same for each machine. There's numerous benefits to doing this. on your local machine is that it's just easier to copy things instead of just using a console. 3, 2, and finally, let's go back. And finally, 3. I think 1, 2. Oh, 4. All right. Okay. All right. So we're in all of them. All right. Okay. So now continuing on. And again, if you've missed any of these steps, please take a look at part 1 of this lesson. All right. So now continuing on, this lesson assumes that you've already heard about Kubernetes, and you have a general understanding of its main job function. So that's already assumed. All right. So in these 2 lessons, we are just setting up, again, our own lab environment while simultaneously looking at what really goes into creating a Kubernetes environment. Now, to set up Kubernetes, we have 5 main components that we actually need to install on each virtual machine. All right. So what are those 5 main components? All right. So these are the key components for installing a Kubernetes cluster. Missed that word there. All right. So you got your container runtime. All right. So your container runtime required to run containers on your system. All right. So examples would be a lot of you guys are probably familiar with Docker. All right. Then you also have container D. Now, Docker uses container D. Underneath Docker uses container D, but it uses kind of like its own version of container D. All right. But you can actually use container D without using Docker. All right. And so you can also use CRI-O. CRI-O is another container runtime. Now, this is actually very important for the Docker lovers, is that Docker, Kubernetes no longer supports Docker containers as of, or the Docker container runtime as of version 1.24. All right. So for this lesson, we're going to use CRI-O. All right. So then you also have kubeadm. All right. So these three binaries, kubeadm, kubelet, and kubectl. These are Kubernetes specific. So kubeadm, Kubernetes managed binary that bootstraps the cluster environment. All right. So that's that. The kubelet is a binary that's responsible for spinning up the pods in the containers. kubectl provides CLI instructions to Kubernetes to do various things, and we'll get to those in more than likely another video. All right, and then you also have your container network interface. So your container network interface, the purpose of that is to basically create a network, amongst your pods and containers. All right. So these are the components. First, we're going to install the container runtime. So that'll be the first thing. All right. And one thing worth noting, something worth keeping in mind, is that most installation builds are based on open source technology and community driven documentation. All right. So the people behind these projects are very incredible. All right. Many contribute their knowledge and time for free to help others succeed. All right. So that said, not every guide will work perfectly for every environment. All right. And so your operating system version, kernel, system configuration, those things can change the outcome. Right. And so, you can use, ChatGPT, AI tools, and AI searches to point you in the right direction. But really, finding the right documentation is a skill within itself. I actually had to go through a couple of different CRI-O documentations to find out which one that actually works for this particular demonstration. And this is the one I landed on. All right. So this will basically I'll have as always, I'm going to have the documentations, the links in the description. All right. So again, first we're going to install CRI-O. All right. So again, this is the container runtime. Very important. All right. So as you see here, This is the first step in the process. So let's go ahead and create these environment variables, Kubernetes version and cryo version. All right, so let's do that. All right. And we have to do these on like really do this on each node. All right. So this is very important as well. Let's do all this as root. Yeah. Yeah. So yeah, instead of, we can use sudo, but let's just do everything as root. All right. Again, let's take a look at that. All right. So Kubernetes version. Okay. Okay. Cryo version. Okay. And so we're just following the instructions of the documentation. So these environment variables are going to be referenced later on in the documentation. So let's make sure everything is there. Okay. All right. So that's there. B. All right. So env is just a command to check your environment variables. So, all right. So those are there. All right. That's good to go. All right. So following this documentation. All right. So it says distributions using RPM packages. These are Red Hat environments. All right. So we want Debian packages. All right. So it says here. All right. First you run apt-get update. We can go ahead and do that. All right. And in fact, first, let's do this. It doesn't matter. I was going to run a script, but yeah, I'll just go ahead and copy it. All right. Let's do that. Copy this. Okay. Same thing here. This is worker 2. Okay, and so why am I running everything as root? Well, that's because, you have to have super user privileges to install a Kubernetes cluster. So, just might as well. All right. Okay, and all right, so what's next? All right, apt-get update. All right, so we need to update the machines. Update. Not update the machines, but update the repo list. Update. This may stall for a second. Okay, that's still going. All right, so next, all right, so you add the Kubernetes repository. So really, you can just copy this directly. Copy this into a script. All right, so add KH repository.sh. All right, so this is a little bit of shell scripting. Okay. Turn this into an executable. And then run it. Okay. Not found. All right, so let's take a look at that. All right. GPT package. Let's try this just individually. See what's going on with this. Okay, well, that worked. All right. Okay. Let's just copy and just run it line by line. Okay, that worked. All right. Actually, let's try this. Sorry if I'm actually jumping around in instructions. Okay, sounds good. All right. Okay, so I ran that. Let's see here, copy that. All right, and this is just adding the app repository, the Kubernetes app repository and a Cryo app repository, so you can download the appropriate packages for Kubernetes, the binaries, and also you can download the Cryo packages. Without adding these, then you wouldn't be able to download them. You would not be able to run app install Cryo. Okay, and so let's go ahead and now you run app get update again because you want to upload the new repo list that you just added. All right. And so now you install these. All right, so it's going to be Cryo, Kubelet, kubeadm, and kubectl. All right, so while that is installing, all right, so let's go ahead and do the same thing for the next 3 nodes. I'm going to try to run this again. See what happens. K8. Let's do BNSH. All right. Let's see. Okay, that did work. All right. So that worked. All right. So let's go ahead. Same thing here. H. And SH. Okay, and same thing, make this an executable. Require repository, and I'll run it. Okay, that's that. All right. Same thing here. Kubernetes repository. All right, so this is working O2. All right. And oh. Paste. All right. Turn this into an executable. Run it. That's good. All right. Require repository. Add that. Okay. Let's see. Okay, turn this to an executable. Right. Run it. Okay. Clear that. Well, I'll leave it. All right. Actually, clear that. Okay. And finally, the third worker node. Add K8 repository H. Okay. All right. Make that executable. Run it. Okay, and require repository. Okay. SH. Okay. All right, now. Okay, so with these, app get update, app get update again. So you just added 2 new repositories to your system. So you need to update the repositories. All right. All right, and the same command we ran here. Just run it on these nodes. All right, so now you can install Cryo, install kubelet, kubeadm, and kubectl. I'm just gonna copy this. I don't want to type that out again. What's going on? Okay, it was moving too fast. All right. Okay. All right. So these 3 nodes at the bottom, these are your workers, and this is your master at the top. This is already done. All packages, all binaries have been installed. All right, so we're just waiting on the 3 worker nodes to update. Well, and to download the necessary binaries. Okay, didn't have to do this. I'm not certain what that was. If that comes up, just hit OK, just like I did. Okay, and so still waiting on worker 1 and worker 3. Okay, all right, so, all right, now, very important step. All right, so when we install Kubernetes, all right, so kubeadm is going to, that's the main tool, right? That's the main tool that bootstraps the environment. And then so it initializes the Kubernetes environment, and then it generates like tokens. So each node can then join the environment and it can establish the parent-child relationship. But in order for kubeadm binary to run, it clashes with swap. All right, so swap is going to be, by default on many Linux distributions. When you install an operating system, it allocates swap space. Swap space is for like kind of like extended memory. And so it just helps out with kind of like memory allocation. All right, let's just say that. All right, and so kubeadm has a problem with it. All right, so basically what we're going to have to do is disable swap. All right, so how do you do that? All right, so your swap is, again, it's actually just kind of like dedicated space on your disk. Again, just allocated for this space on your disk. This extra space is allocated for memory allocation. All right, and so you can just comment it out. All right, so you go to your fs tab file. All right, and you comment out the mount point for the swap device. All right, so that's basically what you're doing with this. All right, so you want to do that on each machine actually. Now, this again, it comments. So you're commenting it out. All right, and we're gonna reboot the machine, and it's definitely, and what's gonna happen is it's not gonna mount the swap device. There's other ways of doing this. You can You can actually temporarily disable swap. For this demonstration, we're just going to remove it all together. All right, and so now we can just go ahead and reboot. Actually don't have to do that. Let's do that. This is gonna mount all. And let's see if swap is mounted. Okay, so I believe by running that mount all command, it remounted everything. I'm just going by memory right now. So I'm trying to avoid having to reboot this machine and, you know, just making a process longer than what it has to be. All right, so we'll see if it works. So we'll just try this node first. If it doesn't work, then I'm just going to reboot the machine. All right, so let's go back to the instructions. Okay. All right, so we have everything installed. And so I'm actually kind of like demonstrating kind of like a shortcut to things. All right. There's certain things that I know that's already in place when the operating system is installed. All right. Like it provides you with instructions, like for instance, to these are kind of like system provisioning instructions, you know, set up port forwarding, mod probe, BR net filter. And this is a swap off. This is a temporary swap off command that I was referencing earlier. You know, you can just run this. I'm just removing and swap altogether. All right, but again, some of these commands, you know, I know for this particular demonstration we don't need to do. Like we don't need this for now. All right, so anyhow. All right, so installing kubeadm. All right, so this is the Kubernetes documentation. We can just follow this for like actually it's going to be this one. All right, for the remaining steps. All right, so at this point, all right, so we only have one container runtime running. All right, cryo. So really at this point, we could run kubeadm init to go ahead and get started. All right, and so all right, so I have a feeling that this has something to do with swap. All right, so we're just going to go ahead and reboot. All right. All right, so rebooting the master node. Okay, all right, so let's log back in. Okay. Let's try this again. Okay, all right, so what's this about? Okay, all right, so actually, port forwarding is not set. All right, so let's go ahead and follow the instructions here. that recently, but for whatever reason, I have to do it now. All right. So run this sysctl command. Okay. Now run this. Okay, so good to go there. All right, so you run the Kubernetes command. All right, so that's going to be run on the master node. All right, so this is the parent node. All right, and so you run Kubernetes there. All right, and so this is bootstrapping the environment, establishing the master node as the parent. And then what's going to happen is eventually we're just going to join these three to the parent. All right, so let's wait on that. And actually, while we're waiting on that, what we can do is let's run this on all of them. Okay, same thing, roll. CTL value at IP4 and I thought this actually this sysctl key value pair was already set. I thought this was already set IP4 to 1, but apparently it's not. So filter, yeah, net. Okay. All right. Okay, now those are set. Swap is off. Okay, and as you see here. All right, so let's do something. 1 second. Key. Yeah. All right, so it ran through everything, pre-flight checks. All right, so the pre-flight checks is going to make sure, you know, all the that you have the appropriate underlying operating system configurations in place. As we saw an example of that when it showed me that I didn't have the appropriate I didn't have IP4 set, so that was a check. All right, so we performed that, and as we see here, you know, no errors immediately. All right, so no errors. Okay, and then it provides you with a set of instructions. So this is what you want to do. All right, so this means everything has been initialized or bootstrapped successfully. All right, so when you see these sets of instructions right here, your Kubernetes control plane has been initialized successfully, then it provides you with this. So you want to actually copy this. All right, so you want to copy that. You're going to need it. All right, so you want to keep that. All right, so I just copied that here. All right, set this off to the side. All right, and so now so again, I have this off to the side. So I'm gonna clear this out. Actually, no, I can just keep this here. All right, so I switch back to the regular user. Now you want to switch. All right, so you've installed Kubernetes as root, which we needed to do. KubeADM is going to require super user privileges, right? Now, when we run our Kubernetes commands, such as kubectl to perform various functions, Kubernetes specific functions, spinning up Kubernetes environments, deployments, and the various Kubernetes resources that we'll get to later. You want to do that as a regular user. All right, so you switch back to your main user. All right, and then you run these commands. And in fact, as I was talking, it actually tells you that. So you need to run the following as a regular user. All right, so okay, that's good. All right, so copy this. Okay, and now, all right, so you don't have to worry about this. All right, so this is what you want to do here, all right, as a regular user. And now what you can do is you can run this command here for each one of your worker nodes. All right, so again, kubeadm, just run it as root. All right, so copy that. So now what you're doing is you're joining these three nodes to the master node. And it gives you a token to do so. And it references the node IP address, as well as the port that the Kubernetes API server is listening on, which is 6443. Oh, I still have swap. That's right. So in this situation, we've already commented out swap. All right, so I don't want to reboot at this point. So now we can just run swap off. All right, so let's see here. Could not connect to the runtime. Okay, so I believe that, all right, we downloaded the container runtime, but it also, there it is, cryo service. That's the step that we forgot to do. All right, here's what we can do. All right, now systemctl status cryo.service. That's what we forgot to do. All right, now it's running. Okay, now join it. Okay, so it joined. All right, so here, same thing. Let's run swap off here. All right, and ETL able now. Same thing. Off. Now cryo.service. Okay. All right. So now we can join these. All right. All right. So the first one has been joined successfully. Let's do the next two. Okay. All right. So now these workers have been added. All right. And so we can verify that by running a Kubernetes specific command. So all right. So we have the kubectl. So Kubernetes CTL get node. All right. Now, so the master is a control plane. We got worker 1, worker 2, worker 3, but it says it's not ready. right? So how do we get this status to ready? The final step in this process is going to be adding the container network interface. All right. And so if we remember, all right, so that's this step here, third-party solutions that provide networking between your host machines and all cluster components. We're going to use WeaveNet. All right. And so let's find that. All right. Let's just look for it. Weave install. Okay. Let's click on this. All right. So just copy this. All we have to do is just copy this command. All right. So this is Weave is a third-party service, again, that provides networking functionality between all of your cluster nodes. All right. And so it does that as a distributed service itself. So it actually runs within the Kubernetes environment to provide this networking. So so it's a Kubernetes specific configuration. All you have to do is just run this one command, kubectl apply. All right. And so let's do that. And we're going to run that on the master node. Okay. And it's that. All right. And we give this a minute or two. And then it should say ready. The status should be ready for all of our worker nodes. So let's do 0 node. Okay, still configuring. Okay, as we see, worker node 1, 2, and 3 are ready, and then Kubernetes master should be ready in just a moment. All right, still going. Okay. And now everything is ready. All right. And so we now have a functional Kubernetes environment. And so these are the different namespaces for all of the base Kubernetes components. All right, we'll discuss some of these in the near future. Node, lease, kube, public, kube, system. You can actually do things like get all, kubectl get all in a kube system namespace. So this command basically just get all resources in the kube system namespace. All right, and so here, if you guys remember, a moment ago when I mentioned that the actual third-party CNI container networking interface, it runs as a distributed service itself within the Kubernetes environment. So that's WeaveNet, and these are some of the WeaveNet resources here. All right, so it runs as a deployment. Well, actually as a daemon set. So we'll discuss what the difference is between those Kubernetes objects later on. All right, and so there you have it. We have a fully functional 4-node Kubernetes cluster running Ubuntu 22.04 LTS. And this is what the process is like. Whether you're, so we just configured this in our lab environment. This is, say, it's not much difference in an enterprise environment. Many of these steps are, roughly the same. So there you have it. If you followed along, hopefully you were able to successfully achieve the same outcome. These lessons definitely assume some level of understanding of systems administration. The process of setting up your own Kubernetes cluster sometimes can be a little challenging because different Linux OS distributions are sometimes configured differently, which impacts how you install services on them. This is one of the reasons why cloud services like Amazon EKS and Google GKE are so popular, because it does not take this level of understanding or configuration to spin up a KH cluster in those environments. However, I'm a really big advocate for controlling your own environment. And at some point in the near future, I'll do many videos on breaking down and interacting with the different components in a KH cluster. But in Google GKE and Amazon EKS, you don't control the Kubernetes control plane. And as a result, you lose many capabilities to optimize as well as lock down your Kubernetes environment. I'm an advocate for cloud services, and we will definitely demonstrate some on this channel, but I advocate for sensible and strategic use of the cloud. So in other words, I'm not cloud everything. I think that's a silly approach. But anyhow, I don't know about you guys, but I thought that was a lengthy process to install a Kubernetes cluster. So in one of my next videos, I'm going to demonstrate the benefits of using Ansible to configure a Kubernetes cluster. It's actually going to spin up a cluster in minutes. So definitely stay tuned for that. Like, comment, and subscribe to the channel as well. Thank you guys for watching.